Today we're working on 4.1 polynomial functions. The first thing they're going to ask you to do is verify if you have a zero or not. So they'll give you a function or an equation and they'll give you an x value and you have to verify that it's a zero. Well, if they give you an equation like they do here, you're just going to plug your -1 in and see what happens. So we've got 9 times -1 squared minus 4 times -1 equals 2 times -1 cubed plus 15. So -1 squared, that's a positive 1, so we'll get a 9 here. A negative times a negative is a positive. We've got a -1 to the third power, so that's a -1 times 2, so -2 plus 15. And we get 13 equals 13. That's what you want to happen. Okay, so if they give you a problem that's an equation, you want both sides to be the same number. That's what tells you that it was a zero. Okay, so whether the problem is asking you to verify or if they're just asking you, is it a zero, that's what you're looking for. So if you get the same number on both sides, you know you were given a zero. Let's try another way. So they might give it to you in function notation. So I've got f of x equals 23 x to the 7th minus 12 x to the 5th. And they want you to test x equals 0. Okay, well that's not bad to plug in 0, but let's see what happens. So we've got 23 times 0 to the 7th minus 12 times 0 to the 5th. Well, of course, that's going to give us 0. But that's what you want to happen. When they give it to you in function notation, if it's a 0 of the polynomial, you're going to get 0 for an answer. Okay, so if it's in equation form, you want the same thing on both sides. That's what tells you that that's a 0 of the polynomial. And if it's in function notation, you want it to equal out to be 0. That's what's going to tell you it was a 0 of the polynomial. Okay? All right, the second part of this section is the end behavior of a polynomial. So I like to make this little table. I've got leading coefficient, and that's going to be either positive or negative. And I've got the degree, and that's either going to be even or odd. Okay, so you've got 4 choices. You're going to first look at your degree. If your degree is even, that tells you that both sides are going to go the same direction. Okay, so you're looking at the end behavior. What are the ends of the graphs doing? Are they either going up or down? Okay, if the leading coefficient is positive and it was even, they're both going up. If the leading coefficient is negative and it was even degree, they're both going down. Okay, so even tells you they're going the same direction. Some people even like to put same underneath here to remind themselves. And odd, they're going opposite directions. And what I like to remember is the right side is more important. That helps me remember which is which. Okay, so if it's positive, that tells me the right side is going up. The other side must be going down because it's odd and opposite. If it's negative, then the right side is going down. The left side must be going up because it was odd, it was opposite. So those are the 4 different situations. So let's take a look at a couple examples. Part A, they give me f of x equals 5x to the 5th plus 4x to the 7th plus 12. Okay, well first figure out what is the degree And what is the leading coefficient? I like to just put LC for leading coefficient so I don't have to rewrite the whole thing. Well, remember, for the degree, you're looking for the highest exponent. My highest exponent here is 7. It might not be in order, so make sure you look through the whole problem and find the highest exponent for your degree. My leading coefficient is connected to the term that has the highest exponent. So the leading coefficient is 4 in this case. Okay, so my degree was odd. My leading coefficient was positive. Okay, well, odd means they're going to go the opposite directions. Positive is telling me the right side. So the right side goes up, left side goes down. And that's all you need to put. Okay, oh, and sometimes you see people put the squiggly lines in between because we don't know what's happening inside the graph. We're just talking about the end behavior. Okay, B, I've got h of x equals negative 6x to the 5th plus 2x cubed minus 7x. Okay, again, I'll find the degree and the leading coefficient. Okay, the highest exponent in this problem is 5, so that's my degree. And looking at that term, negative 6 is my leading coefficient. So I've got an odd degree and a negative leading coefficient. So again, that tells us that they're going to be opposite, and the right side is going to go down. So see, I don't even look at that chart that I gave you because I've told myself how to memorize it. Feel free to look at the chart until you're comfortable, but find a way to memorize it so you don't even have to look at the chart. One more example, f of x equals negative 2x squared times x plus 4 times x minus 4. Okay, well, it's in factored form. You can't find the degree when it's in factored form, so you need to multiply it out. Or there is a shortcut. You don't have to multiply it completely out. Look at each of the factors. This factor only has one term, so I'm going to have to use this term. This factor, this is the term with the highest exponent. And in this factor, this is the term with the highest exponent. So you just need to take the terms with the highest exponent from each of the factors and then multiply them together. So we'll get negative 2x to the 4th. Well, that can tell you your degree and your leading coefficient. So my degree is 4, and my leading coefficient is negative 2. So I've got an even degree and a negative leading coefficient. This tells us they're going to be the same, and it's negative, so both sides are going to go down. And we had a very short section today, so I'll see you next time.